GMS supports 2D and 3D geostatistics, or interpolation. Interpolation is done from discrete points called scatter points. Scatter points can be created in GMS, or imported, or created from other objects. I will import some scatter points by copying from an Excel spreadsheet and pasting into GMS using Ctrl-V. There is a heading row in the data, so I will turn on that option and click Next. Then I will set the type to 2D scatter points, assign the column IDs, and set the name of the dataset. After importing the scatter points, I create the bounding grid. I'll make a grid that is 70 cells in the X dimension and 40 cells in the Y dimension. Several interpolation schemes are supported in GMS. This video will demonstrate two options. Let's first use the inverse distance weighted option. And for the nodal function, we'll use gradient planes. Now I'll interpolate to the 2D grid. The Z values are set to the new dataset. Next, I'll demonstrate the kriging options. First, I will create an experimental variogram with the default options. After the experimental variogram is computed, I will then define a model variogram. Using the Gaussian option, I will enter values for the nugget, contribution, and range factors. Now I'll interpolate the 2D grid. GMS can also use any interpolation option to interpolate from scatter points to layers of a ModFlow model. This is demonstrated in a separate video. Using the Project Explorer, I can switch between the created datasets to view the differences in the interpolation methods. GMS has many of the same interpolation options for 3D. Here I have imported a 3D scatter point set and created a bounding grid. The points have been interpolated to the grid nodes using IDW, and we see the results using an isosurface. Now I'll interpolate using the kriging option. Notice the change in the isosurface as a result of the interpolation.